Hello everyone, I am Pallavi. I am studying in Sri Venkateshwara College of Engineering from first year ECE branch. Today I am going to discuss about corrosion control methods. Corrosion control is crucially for preventing the material due to chemical reaction with their environment. Various methods are employed to protect against the corrosion and they can be categorized into several types. Here are some common corrosion control methods: design and selection of materials, protective coating and cathodic coating. Protective coating are a crucially component of corrosion control, providing a barrier between the material surface and the corrosive environment. These coating help to prevent or slow down the corrosion process, extending the lifespan of the material. Here are some common types of protective coating. One is metal coating and another one is inorganic coating. Metal coating is a process in which a layer one of the metal is applied to the surface of another metal. This coating is typically done for the various purposes, including corrosion resistance, decorative finishing, increased hardness, or improved electrical conductivity. Anodic coating, also one of the metal coating. The coating metal is anodic to base metal is called anodic coating. For example, galvanization. Galvanization is a process of coating iron or steel with a layer of zinc to protect it from the corrosion. This protective zinc layer acts as a barrier, preventing rust and extending the lifespan of the metal. The galvanization process followed these steps. First one is cleaning. The steel object is thoroughly cleaned to remove any dirt, grease, rust, or mild scales. This is often done using the combination of degreasing, pickling, and rinsing. Fluxing. The cleaner steel is dipped into a flux solution, typically a zinc ammonium chloride solution. This helps to remove any remaining oxide and prepare the surface for the bonding with the molten zinc. Dipping. The prepared steel object is submerged into a bath of molten zinc maintained at around 450 degrees Celsius. The zinc reacts with the iron in the steel, forming a series of zinc iron alloy layers. Withdrawal. After a sufficient time in the molten zinc, the object is slowly withdrawn, allowed to excess zinc to drain off. As the zinc cools, it solidifies, forming a protective coating on the steel. After that, we should do cooling. The galvanized object is allowed to cool naturally or is quenched in water to accelerate the cooling process. Inspection. The galvanized coating is inspected for uniformly thickness and adherence. Any imperfection may require further treatment or touch-ups. Optional finishing. Painting. For additional protection or aesthetic purpose, a paint layer may be applied over the galvanized coating. Passivation. The chemical treatment can be applied to create a passive layer on the zinc surface, enhancing corrosion resistance. Second one is inorganic coating. Inorganic coating refer to protective layer applied to surface using material that do not contain carbon hydrogen bonds. These coatings are composed of minerals, metals, ceramics, or other inorganic compounds. Inorganic coatings are known for their durability, resistance to high temperature, and stability in harsh environment. For example, anodizing and phosphating. Anodizing is a process that involves enhancing the natural oxide layer on the surface of certain metal, particularly aluminium, is a creating a thicker, more durability and corrosion resistant layer through electrolytic oxidation. Anodizing of aluminium. Aluminium surface is cleaned thoroughly to remove any contaminants such as grease, oil, or dirt. This step is essential for ensuring proper adhesion of oxide layer. The aluminium is often immersed in the degreasing solution to remove any remaining oils or greases from the surface. In some cases, aluminium is etched in an alkaline solution to create a microscopically rough surface. This enhances the Addition of oxide layer. The cleaned aluminum is immersed in an electrolytic solution, typically sulfuric acid. The aluminum serves as a anode in the electrolytic cell. The electric current is passed through the electrolytic solution. Oxygen ion are released at the anode and they combine with the aluminum to form aluminum oxide. The aluminum oxide layer grows on the surface of the aluminum. The thickness of this layer can be controlled based on the factors such as duration of the anodizing process. If desired, various color methods can be employed during or after anodizing. This can be involved introducing pigment or dyes into the porous oxide layers, allowing further range of colors. The anodizing aluminum may undergo a sealing process. This involves closing or partially closing the pores in the oxide layer to enhance corrosion resistance. Sealing methods include hot water sealing or chemical sealing. The anodized aluminum is visually inspected for the quality of the oxide layer, color uniformly, and overall adherence of to specification. Cathodic protection. Cathodic protection typically referred to type of corrosion protection method called cathodic protection. Cathodic protection is a technique used for control the corrosion of the metal surface by making it the cathode of an electrochemical cell. It is divided into two techniques. First one is sacrificial anode technique and impressed current technique. Sacrificial anode technique. The sacrificial anode technique is method used to protect metal structures from the corrosion by employing a sacrificial metal that is more easily corroded than the structure itself. In simple terms, sacrificial anode, a piece of metal that is more reactive and tends to corrode more readily than the metal structure you want to protect it. Electrochemical cell, the sacrificial anode and the metal structure to be protected from the electrochemical cell. In this cell, the sacrificial anode becomes the anode, means positively charged electrode, and the metal structure becomes the cathode, means negatively charged electrode. Corrosion prevention. Since the sacrificial anode is a more prone to corrosion, it corroded sacrificially, releasing electron in the process. These electrons flow through the metal structure, preventing its own corrosion. Essentially, the sacrificial anode sacrifices itself to protect the main metal structure. Replacement of sacrificial anodes. Over time, as the sacrificial anode corroded, it needs to be replaced periodically to ensure continued protection of the main metal structure. Impressed current technique. External power source. An external power source, often a direct current power supply, is connected to a metal structure to be protected. Inert anodes. Instead of using sacrificial anodes that naturally corrode, that immersed current technique employs inert anodes, typically made of material like a mixed metal oxide or platinum coated titanium. Electrochemical cells. The metal structure becomes the cathode, means negative charged electrode, and the inert anode becomes the anode, means positively charged electrode, forming an electrochemical cell. Electron flow. The external power source drives a flow of electrons from the anode to the cathode. This flow of electrons counteracts the natural corrosion process that would occur on the metal structure. Preventing corrosion. By impressing the controlled electric current onto the metal structure, the technique actively prevents the metal from the corroding. This particularly useful in situations where sacrificial anodes may not be practical or cost effective. These are the methods how to control the corrosion. Thank you for watching my video.